Hello dear students, this is your Jagam sir from Physics with Jagam sir Academy. See here, we are going to start vectors as a separate chapter for your understanding. Now, this will help you in so many ways while you are writing your original examination, right? There might be directly or indirectly questions are coming from this topic, but the foundation of this topic is most important for your examination point of view. And here I am going to discuss from 0th level to the level which is appropriate for your final examination. Okay, now the chapter name is vectors, the topic name is vectors. In this vectors topic, first of all, we would like to know what is vectors and scalars. Before vector, let us see what is scalar. Scalar means the physical quantity which has only magnitude but it does not have any particular direction. That is only magnitude, magnitude, but no direction. No direction. This is what we call as scalar. We can have example mass, energy, mass, energy, example, etc. See here, Vedant, see here, dear students, we cannot say I have a certain amount of mass in east direction or certain amount of mass in west direction. So we can say that we have some amount of mass in my hand. That might be 2 kg, 3 kg, whatever that might be. We have some amount of mass that we can represent. So next point is addition of scalar. Addition of scalar. See how we can addition, how can we add scalars? Let us say m1 is equals to 2 kg and m2 is equals to 3 kg. Then what is the total mass? Total mass is equals to m1 plus m2, which is equals to 2 plus 3. Directly we can say 5 kg. Directly we can say 5 kg, which is similar to normal addition. Normal addition, we no need to have any proper formulas for adding scalar quantity. Okay, now let us see what is vectors. Let us see what is vectors. Vectors means which has magnitude, direction, and the vectors to follow law of vector addition. Law of vector addition. It has to follow law of vector addition. And here law of vector addition is not similar to the case of scalar addition, and it has a particular formula which we will derive in today's class only, right? Now here we have magnitude, direction, for example displacement, velocity, velocity. See here, Nana, velocity means 5 meter per second, 5 meter per second, and we can say that it is in east direction or in west direction, north direction, south direction. So particular velocity we can represent in which direction the object is moving. So the direction is we are representing along with the magnitude means it is a vector, and again along with these two quantities it has to follow law of vector addition, which we will see in our today's class only. Okay, then next one is we have seen now what is vectors and what is scalars. Then next topic, representation of vectors. How we need to represent a vector. See here, let it be a vector, let it be a vector. This is the representation of vector, and here this represents magnitude, magnitude. For example, if it is 3 meters, if it is 3 meters, then a vector which is higher than the length of the 3 meter, so we can say 5 meter or 6 meter. And suppose if it is less, we can say 2 meter, like that. Okay, and the next point is here, here this is called tail, this is called head. This is how we have to represent a vector. This is how we have to represent a vector. So this is the concept of representation of vector. And next point is vector addition by analytical method. This is what I had already told you. For example, let us, if we consider a vector, that vector must be having magnitude, direction, should follow vector law of addition. That's what we are discussing now. That is here triangle law. I am explaining initially triangle law. The triangle law, suppose here A is one vector, let us assume A is one vector, and here B is one more vector. B is one more vector. And remember, whenever we are drawing like this, here the angle representation should be lies between two tails of the vector. So for that purpose, we are extending vector A until this location. Now this will be the head and this is the part of the tail. Clear? So this is one tail, this is the part of the tail. Then we can consider it is the angle between the two tails. This is the condition that is we had satisfied. Now this B is having two components. And for your clarity, I will explain you with the Pythagoras theorem. Suppose, let us assume this is a right angle triangle. This is a right angle triangle and this is angle theta. Now, let us assume this is x, this is y. This is x, this is y. This is b. Let us say it is b. Can I say now sin theta is equal to y by b, y by b. Therefore, y is equal to b sin theta, b sin theta. Similarly, cos theta is equal to x by b. Therefore, b is equal to, sorry, therefore, can I say just wait better, just wait for a while. Board has been handled. Just wait for 1 minute. It will be clear soon. Right. Then we can say x is equals to b cos theta. That means this becomes b sin theta now equals to, then this becomes b cos theta. So the adjacent line will be b cos theta, opposite line will be b sin theta. And in the vectors, we have one concept. If it is a vector, we can write its parallel vector at this location. We have this as a condition. Okay, so we can remove this one now, and we can say this is equals to b sin theta. B sin theta. Now, next point is, see here, can I say now this is, if it is b means this becomes b sin theta, this becomes b sin theta, and this becomes b cos theta. Am I right? This becomes b cos theta. Now, right. Now, this will be the resultant. This will be the resultant. That resultant is equals to, according to the diagram, resultant is equals to, by using Pythagoras theorem, PT, we can say R is equals to under root of A plus B cos theta square plus B sin theta square. B sin theta square, that is opposite by adjacent. Okay, now R is equals to under root of A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Okay, now R is equals to under root of A square plus B square sin square theta plus cos square theta plus 2AB cos theta. 2AB cos theta. which is equals to r is equals to under root of then sin square theta plus cos square theta is equals to 1. So we can write it as a square plus b square plus 2ab cos theta. And remember, this is the addition of vectors. This is how we have to add two vectors. Now I can give you an example. And before that, I would like to tell you one small concept again. Here, this resultant is making, let us say, an angle phi. Resultant is making an angle phi. Now, tan phi tan phi is equals to opposite b sin theta by a plus b cos theta. A plus b cos theta. Okay. Now, sir, can you give an example for our clarity? Yes, beta. Yes, dear students, I can give. Suppose this is with 5 meters displacement value. This is with 4 meters displacement value. Then how much would be the resultant? And again, I am saying resultant should be lies between two vectors. And here, this is I am assuming as one vector. So the angle should be lies between these two vectors, which I am considering as theta. The angle between 5 meters and 4 meters is theta, and angle between resultant and downward adjacent vector is phi. Right. So we can substitute in the formulas. So R is equal to under root of A. This is A. This is B. So 5 square, 4 square, 2 into 5 into 4 cos. What is the angle between 5 and 4? That is, let us assume 30. Let us assume 30. Cos 30. Otherwise, 60. Let us assume it is 60. Theta is equals to 60 degrees, and this is phi. Now this becomes r is equals to under root of 25 plus 16 plus 40 1 by 2. This is r is equals to under root of 41 41 plus 20, which is equals to root 61. This is the resultant of addition of two vectors. And if it is scalar, we can add 5 plus 4 is equals to 9 if it is scalar. But if it is, these are the vectors. So this is the procedure we have to follow for the addition of two vectors. Okay, and how much is the angle made by the resultant with respect to adjacent? That is again tan phi is equals to b sin theta by a plus b cos theta. Now b means here 4 sin, and angle between these two is 60 degrees by 5 plus 4 cos 60 degrees, which is 4 root 3 by 2 5 plus 4 1 by 2. So 2 2. Then answer becomes 2 root 3 by 7. This is the angle tan phi. Resultant is making angle with the a vector. This is the resultant made by angle a vector. Okay. Now let us see next one is parallelogram law of vector addition. Parallelogram law of vector addition. Right. See here the proof for the triangular law of vector addition and parallelogram law of vector addition remains same. So let us say here this is one vector A and this is one vector B. Sorry, this is parallelogram law of vector addition means again hanging. Give me 1 minute at least. Probably it will be fine within 1 minute. right? This is A vector, this is B vector, B vector. Now this is resultant, as I told, this is resultant. That means we can extend A vector. Similarly, we can extend B vector. As I told you, we can represent a parallel vector parallel to each other. Now this B will have, suppose, theta. That means this is theta. Obviously, if it is theta means this one is also theta. Clear? Then this becomes B sin theta, which I had already clearly explained. This becomes B cos theta. Okay, this line becomes B cos theta, this one becomes B sin theta. And again, can I say it is looking like right angle triangle again? Now, if it is looking like right angle triangle, which is similar to the triangular law of vector addition. Now, we can directly say R is equals to, the proof remains the same, that is opposite square by adjacent square under root of, that is resultant, which is we had already proved in the vector law, triangular law of vector addition. So the resultant becomes A square plus B square plus 2AB cos theta. This is the resultant. Again, resultant angle with respect to A vector is tan phi is equal to B sin theta by A plus B cos theta. Okay, this is the same resultant for the both the theorems. And next part is special cases. Let us see some special cases. Right. See, we have seen that R is equal to under root of A square plus B square plus 2AB cos theta. Now, if theta is equal to 0 degrees, what does it mean? That means here we have A vector with a magnitude of 5 meters. Here we have B vector with a magnitude of 3 meters. Okay, and these two are having 0 angle between them. Now, that means R is equals to under root of A square 5 square 3 square 2 5 3 cos 0. What is the value of cos 0? Cos 0 is equal to 1. So obviously the resultant becomes 25 9 plus 30 into 1, which is equals to R is equals to under root of 34 plus 30, which is 64, which is 8. 8 is the resultant. Now I can say if these two are having 0 degree angle between them, like this representation, obviously total length of the vector becomes A plus B. That resultant is equals to 8 meters. And the addition of 5 meters and 8 meter vector, maximum value is 8 meters, and we could not get more than 8 meters when we are adding the 5 meter and 3 meter by using vector law of addition. So we can say our max value is equal to A plus B at 0 degree, at 0 degree. Clear? Similarly, let us see for the second case. It is one case, and let us see for the case 2. Case 2, when theta is equals to 180 degrees. Theta is equals to 180 degrees. When theta is equals to 180 degrees means, suppose A is 5 meters as usually, B is 3 meters. So this becomes A, which is representing in the rightward direction. So next vector should be 180 degrees. That means it has to be represented in the opposite direction. 180 degrees means in the opposite direction with a magnitude of 3 meters. Okay. Now we will see how the resultant will be. R is equal to under root of 5 square 3 square 2 into 5 into 3 cos 180. What is the value of cos 180? Cos 180 is equals to minus 1. So 3 square minus 30, which is equals to 34 minus 30 is equals to root 4, which is 2 meters. Resultant is 2 meters. What does it mean? That means if two vectors are adding with the angle of 180 degrees, we will get minimum value, and at any cost we could never get minimum of this value. That means R minimum is equals to a minus B at 180 degrees, and we would never get minimum of this value at any angle other than less than or greater than 180 degrees, and this is the condition. So maximum is happening at 0 degrees, minimum is happening at 180 degrees. This is the most important condition, that is A plus B is the case for maximum, A minus B is the case for minimum. Then next condition is condition 3. Condition 3. Let us see it, theta is equals to 90 degrees. What will be the answer? See, R is equals to, again I am considering, this is vector A with 5 meters, this is vector B with 3 meters. Then 5 square, 3 square, cos 90. What is the value of cos 90? Cos 90 is equals to 0, right? So it will be 25 plus 9 becomes 0. This will become 0 because cos 0 means everything will be 0. Then this becomes root 34. Root 34 will be approximately 5.82 or 9. 5.8, 5 or 5.9, like this value. So what is the maximum value here? 8. When we are seeing for A plus B, what's the minimum value is 2. So from 0 degrees to 180 degrees, that is 8 to 2, this answer is in between 5.8 or 5.9. Okay, that is, it is proved that maximum value, minimum value is, sorry, the value other than 0 degrees or 180 degrees, that value is lies between the maximum and minimum values. Clear? It is what are the different special cases for the addition of two vectors. Chalo. Now let us go for the next concept, subtraction of vectors. See here, suppose this is vector A, this is vector A, and this is vector B, and this is resultant. This is resultant. Now the angle between these two is theta, and angle between these two is phi, which we have seen 2-3 times in today's class. Now subtraction of vectors means, here I am adding minus b vector to the a vector. That means here you can easily analyze that if total is 180 degrees means, 180 degrees means, and this is theta, this becomes 180 minus theta. Okay, and then the resultant, let us assume making phi 2 as the angle. Clear? Now, how can I find the resultant value? So, R is equal to under root of A square plus B square plus 2AB. Now, the angle between A and minus B is 180 minus theta. So, cos 180 minus theta. This is what we have to substitute here. Now, here R is equals to under root of A square plus B bar square minus 2AB cos theta, because cos 180 minus theta is equals to minus cos theta. So here this is the resultant for subtraction of vector. Similarly, what is the angle? And phi 2 is equals to b sine, the angle theta is the angle between a vector and b vector. So here for a vector and minus b vector, the angle is 180 minus theta. So this becomes a plus b cos 180 minus theta. And what is the sine 180 minus theta? That is sine theta only. Then this becomes sine theta by a, and cos 180 minus theta is equals to minus cos theta. So this becomes minus b cos theta. This is tan phi 2. Okay, tan phi 2. And this is the addition and subtraction of different vectors. And along with this concept, let us see some examples. Let us see some examples. Now, example 1. Example number 1. The greatest and least resultant of two forces acting at a point is 10 Newton and 6 Newton respectively. The greatest means maximum value. The least means minimum value. So what I told you, maximum value will take place when A plus B is the condition. A plus B is, they are giving us 10, and the least resultant is A minus B. I had clearly explained you when we are getting greatest value, that is maximum value, or max A plus B, and again I clearly explained the least or minimum value, that is A minus B is 6 Newton, right? Then we will get cancel these two, that is 2A is equals to 16, that is A is equals to 8 Newton. Clear, A is equals to 8 Newton. If each force is increased by 3 newtons, find the resultant of two new forces when acting at a point 90 degrees to each other. That means A vector becomes now, if it is A is 8 meters, 8 newtons means B becomes A, that is 8 plus B is equals to 10. So B becomes 2 Newton. Okay, B becomes 2 Newton. Then the condition is, if each force is increased by 3 Newton, find the resultant of new forces when acting at a point at 90 degrees to each other. So A is increased by 3 Newton, that is 11 Newton, and B is also increased by 3 newtons. So B is originally 2. So 2 plus 3 is equals to 5 newtons. And they are asking us to find the resultant when they are at a 90 degrees to each other. That means we can say resultant is equals to under root of 11 square plus 5 square plus 2 into 11 into 5 cos 90. They are at a 90 degrees to each other. Okay. Now this is becomes under root of 121 25 plus cos 90 is 0. 0. This is equals to R is equals to 146. R is equals to 146 Newton. This is the resultant answer. Okay, then next one is next example, example number 2. If two equal forces have their resultant equal to either, at what angle they are inclined. That means, see, A is equal to B, two equal forces have their resultant equal to either. That means resultant is also equals to A equals to B. Okay, now they are asking us to find what is the angle. That means R is equals to under root of A square plus B square plus 2AB cos theta. This is formula, and the given condition is R is equals to A is equals to B. That means A square, A square, A square, 2A square cos theta. Okay, these two will get cancelled. Then minus A square, 2A square cos theta. These two again get cancelled. Then cos theta is equals to minus 1 by 2. Therefore, theta is equals to 120 degrees. Theta is equals to 120 degrees. Okay. Then next one is two forces whose magnitudes are in the ratio of 3 is 3, 5, right? Given a resultant 28, resultant 28. If the angle of their inclination is theta is equals to 60 degrees, find the magnitude of each force. That means here let us assume A is equals to 3x, B is equals to 5x. Okay, then resultant is equals to, that is R square is equals to A square B square 2AB cos theta. Okay, then R is equals to 28 square. This is 3x square, 5x square, 2 into 3x, 5x cos theta. Now 9x square, 25x square plus 30 30x square cos theta, that is 28 square, 34x square plus 30x square cos theta. Theta is given as 60 degrees initially. Initially they are given in the question itself 60 degrees. So cos 60 is equals to 34x square plus 30x square 1 by 2, that is 15. So 49x square, 28 into 28. So I can write this 49 as 7 into 7 x square, 4, 4. 16 is equals to x square, x is equals to 16, x is equals to 16. So a is equals to the given 3x means 3 into 16, that is 48, and b is equals to 5x, which is equals to 5 into 16, which is 8. Okay, these are the magnitudes of a and b, right? And next one, okay, this is actually root here. X is equals to 4, and this becomes 4, and this is also 4, and this becomes 12, 20, 10, 12, 20. Chalo. Now let us go for the next example. The resultant of two vectors, see here, this is C vector and this is B vector, and here they represented like this. This is B cos theta, this is B sin theta. Because angle is here means obviously opposite angle will be here. So B cos theta, B sin theta, and this is 90 degrees, and this is B. Now they are asking the resultant of two vectors A and B is perpendicular to the vector A, and that means this is the resultant. This is the resultant, and the magnitude is equal to the half of the magnitude of the vector B, and resultant is having magnitude half of the result half of the magnitude of vector B. Okay, find out the angle between A and B. Then what is the angle between A and B? And here this is B cos theta, this is resultant. According to our vectors concept, I had already told you parallel vectors remains equal. So I can say this becomes B cos theta, which is equals to B by 2. So B is answer. Then cos theta is equals to 1 by 2, then theta is equals to 60 degrees. Chalo. This is what is basic elementary topic which we were discussed on vectors. I hope you understood the class, and if you have any queries you can ask me through our YouTube messages, and if you need any help from my side in your preparation you can message me. I will definitely respond to you, and try to follow my YouTube channel Physics with Jacob sir, and have a great day. Take care. Bye bye.